36. If a is not equal to 0, then the limit as x goes to a of x squared minus a squared divided by x cubed minus a cubed equals what? Another problem that we don't need a calculator for. A calculator won't help us here. So let's look and see. If I just were to try to put in x equal to a, or a in for x, substitute that in for x. A squared minus a squared is 0. A cubed minus a cubed is 0. And it would look like it's going to go to a 0 divided by 0. And we're dead in the water there. We can't do anything with 0 over 0. We have to do something a little different. So let's get rid of that. That's not what we're going to try to do. What I can try to do is this, some factoring. And we should know this top one, definitely, no problem. We know this. This should be, hold on, we still have the limit, so I may not forget about that. It's not right if you don't write the limit. Get used to using correct notation. Limit as x goes to a of the top factors as x minus a multiplied by x plus a. It was originally the difference of squares, that's how that factors, and this is the difference of cubes, and you've definitely, well, I'm not saying definitely, but you've seen it before, okay? It's not as common to show up as difference of squares, but it still factors as x minus a, x squared plus ax plus a squared. Okay, I'll extend this little fraction bar. If you don't believe me, multiply this back through x cubed, ax squared, a squared x, negative ax squared, so that cancels out one of the things that we got, negative a squared x, that cancels out another one, minus a cubed, you've got it, okay? It's right there. Alright, and now I can see that I have an x minus a in the numerator, an x minus a in the denominator. Now, they can cancel without any ill effects except when x is equal to a. So if I do this, this function itself doesn't work when x equals a, so x can't equal a for the function, okay? But that's not a problem because the limit as x goes to a, it's when x gets closer and closer to a, but it never actually reaches a, so this is not a problem. I don't need to worry about it. I'm not even going to write it in here because we know that it doesn't show up. It's worth noting that I can't put in a here and still, I can't actually put in a if this were the function, but the limit works correctly. And so I can, for the limit now, plug this in and say, okay, even though I never actually get there, the limit will become what happens when I put this in. So we would get a plus a. Let me put some parentheses, make this a little bit neater, divided by a squared plus a times a plus a squared. That's a lot of a's in there. And so I'm going to end up with, from there, 2a divided by a squared plus a squared plus a squared, 3a squared. And I've got a little bit of reducing I can do. This a can cancel out with one of those a's up there. And I will be left with 2 divided by 3a. My answer choice is D.